Hello, grade 8 learners! This video presentation is for the first quarter week 1 in Mathematics 8. Here's a gentle reminder for everybody. First, do not forget your pen and paper to write your solutions later on. And second, you can always pause and play this video whenever necessary. What you need to know. At the end of the lesson, you are expected to first determine patterns in factoring difference of two squares. Second, factor the difference of two squares completely. And third, appreciate patterns in factoring difference of two squares and in real-life situations. So today, we're going to visually explore a pattern on how to factor completely a type of polynomial, which is the difference of two squares. So by definition, when you have a binomial of the form x squared minus y squared, then we can factor it as the quantity x plus y times the quantity x minus y, which is the sum and difference of two terms. How do we know if the given binomial is a difference of two squares? The difference of two squares is one of the most common. The good news is this form is very easy to identify. That is, the first term and the last term and the values of the variables are perfect squares, which means the exponents are even number and the sign in between them is a minus sign. So, if you have a binomial of the form x squared minus y squared, then we can factor it as the quantity x plus y times the quantity x minus y. So using this general definition, let's see why that actually works out. And we can check this by using the FILE method, or multiplying the first terms, the outer terms, the inner terms, and the last terms where we have x times x equals x squared. X times negative y equals negative xy. Y times x equals xy. Y times negative y equals negative y squared. So, what do you observe with our middle terms? So, we have negative xy and positive xy. Hence, we simply subtract or cancel them out. So, what we have left is x squared minus y squared. And so, again, this is what we started with, the difference of two squares. By the way, what is a perfect square? So a perfect square is a number that can be expressed as the product of two equal integers. So say for example, we have 4. So 4 is a perfect square since we can express this as 2 times 2 or 2 squared. Another example is 49. So 49 can be expressed as 7 times 7 or 7 squared. Another example is 25. So 25 can be expressed as 5 times 5 or 5 squared. Another example is x squared. So x squared can be expressed as x times x or x raised to 1 plus 1 equals x squared. Another example is 36x to the 8. So 36 can be expressed as 6 times 6 and x to the 8 can be expressed as x to the 4 times x to the 4. So we have the quantity 6x to the 4th squared. And we also have 9 over 16x squared. So 9 can be expressed as 3 times 3 and 16 can be expressed as 4 times 4 and x squared can be expressed as x times x. So we have the quantity 3/4 x squared. So when you multiply a number or a variable or a term by itself, the answer is always a perfect square. How do we factor the difference of these squares? Step number 1, we're going to find the square root of the first term and the last term. So, what is the square root of a number? So, square root is a value that when multiplied by itself gives the number. So, say for example, we're getting the square root of 4. So, the answer is 2 because 2 times 2 is equal to 4. Another example is the square root of 49. The answer is 7 because 7 times 7 is equal to 49. Another example is to get the square root of 25? The answer is 5 because 5 times 5 is equal to 25. Another example is to find the square root of y to the 6. The answer is y cubed because y cubed times y cubed is equal to y raised to 3 plus 3 is equal to y to the 6. Another example is the square root of 36x squared. The answer is 6x because 6x times 6x is equal to 36x squared. So, just think of a number which when multiplied by itself will give the number. So finding the square root of a number is simply the opposite of squaring a number. Step number 2, we're going to write the factors. So, how are we going to write their factors? Write the product of the sum and difference of the square roots of the first and last terms. Let's try example number 1. We're going to get the factors of x squared minus 16. What are we going to do? So first, we're going to get the square root of x squared. So the square root of x squared is x. Since x times x is equal to x squared and the square root of 16 is 4, since 4 times 4 is 16. So writing the answer as a sum and difference of two terms, we have the quantity x plus 4 times the quantity x minus 4, which is the final answer. Example number 2. We're going to get the factors of 4a squared minus 36b squared. So what are we going to do? First, we're going to get the square root of 4 squared and 36b squared. So the square root of 4 squared is 2a, since 2a times 2a is 4a squared, and the square root of 36b squared is 6b, since 6b times 6b is 36b squared. So writing the answer as a sum and difference of two terms, we have the quantity 2a plus 6b times the quantity 2a minus 6b, which is the final answer. Example number 3, we're going to get the factors of a squared b squared minus 81. So what are we going to do? First, get the square root of a squared b squared. So the square root is ab, since ab times ab is a squared b squared. And the square root of 81 is 9, since 9 times 9 is 81. So writing the answer as a sum and difference of two terms, we have the quantity ab plus 9 times the quantity ab minus 9, which is the final answer. Example number 4. We're going to get the factors of 9 over 16a to the 6 minus 25 over 81 n squared. So what are we going to do? We're going to get the square root of 9 over 16a to the 6. So the square root of 9 is 3, the square root of 16 is 4, the square root of a to the 6 is a cubed. So we have 3/4 a cubed, since 3/4 a cubed times 3/4 a cubed equals 9 over 16a to the 6. Next, we're going to get the square root of 25 over 81 n squared. So the square root of 25 is 5, the square root of 81 is 9, the square root of n squared is n. So we have 5 over 9n, since 5 over 9n times 5 over 9n is equal to 25 over 81 n squared. So writing the answer as a sum and difference of two terms, we have the quantity 3/4 a cubed plus 5 over 9n times the quantity 3/4 a cubed minus 5 over 9n, which is the final answer. And now it's your turn. Let's see how well did you learn. So, what are the factors of 4x squared minus 36? The final answer is 2x plus 6 times the quantity 2x minus 6. And you are correct. Question number 2. So what are the factors of 16a to the 6 minus 25b squared? The final answer is the quantity 4a cubed plus 5b times the quantity 4a cubed minus 5b. And you are correct. Question number 3. What are the factors of 4 over 81 r to the 4th minus 9 over 64 n to the 8th? The final answer is the quantity 2 over 9 r squared plus 3 over 8 n to the 4th times the quantity 2 over 9 r squared minus 3 over 8 n to the 4th. And you are correct. Well, that's all for today about factoring the difference of two squares. So the most important thing to remember here is to identify the given binomial as difference of two squares and just apply the pattern on finding the correct factors and you're done. Good job, and keep it up as we continue with our lesson the next day. See you then. Thank you for watching.